All right, today we're looking at quadratic formula. And the reason we're looking at quadratic formula is because so far we've learned several different methods. However, each one kind of has its strengths and each one has its drawbacks. What did we start with? What was the first thing we did when we very first started this?
Square roots.
The square roots. Okay, the square roots were the ones where you just added and divided and that was it, and you were done, and you put a plus minus and all was good with the world. Okay, remember then I threw a twist at you and I said, well, what if there's a middle term? Then what do? We'll complete the square. And that was fine, but it was only convenient sometimes. When is complete the square convenient? When can you complete the square and it's nice?
Perfect square.
Well, that's even better, but when it has an even number. Otherwise, you're taking half, and then you've got a decimal, and it's just not pretty. So complete the square works, and it works all the time, but it's a pain sometimes, isn't it? Okay. Well, that's great. And then we also did graphing. We did graphing. When is graphing convenient?
When you have a calculator.
When you have a graphing calculator. If you don't have a graphing calculator, would you really want to sit there and have to draw a graph just to look at the intercepts?
Joel might.
Probably not. Some of us may, but okay. It's also really good when you want an approximation, but you really don't need necessarily an exact answer. You can get a really quick answer. And then we just practice factoring it. And factoring it is by far the fastest if. If what? When would you want to use factoring?
If you don't have a calculator.
Well, no, you don't use factoring with a calculator. Flip the page back over and take a look. When was it easy to do the factoring method?
Standard form.
When it's in standard form and when it had nice happy factors like multiply to get 12 and add to get 7. Oh yeah, it must be 3 and 4. Okay, factoring is great, but how about one of those ones that had numbers in the front and you had to do the box and blah, 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 blah. Was that convenient to factor? No. So each of these is great, but they all have their drawbacks. So let's take a look and see what else we might be able to use. All right, this is about to get ugly. If we had this particular formula, ax squared plus bx plus c equals 0, if we could somehow find a way to get x by itself with all the a's, b's, and c's on the other side, we would have a little magic formula that we could use to solve any problem. That'd be nice, wouldn't it?
Yeah.
Okay. Now, this is brutally ugly. Don't worry, you do not have to be able to replicate this. You just need to be able to follow. Put your pencils down. Okay.
Oh, gosh.
Oh, wait. You better be careful, girl. Look what we're doing on math.
Hey, Mom, help me
Okay,
with this.
folks, you do not have enough math to do all of these steps, but you do have enough math to follow the general process. So, hang on. Let me see if I can make it just a tiny bit bigger. Come on. There we go. All right. Again, you don't have the math to do all of these steps, but you do have enough math to follow along the process, okay? I just want you to know where it comes from. This is not magic. It was not born on a formula chart. It really does come from the formula. Here's what you do. You take away c from both sides to get the x's on one side and the numbers on the other. You remember that step? We take half of b and square it. Does that sound familiar?
Mm-hmm.
Yeah, that's completing the square. Then you write it as a square. Right, that's what we did with completing the square. There's a little bit of simplifying over here that you don't know how to do yet. That's okay. Then we do what? What do we do when we have a square? We take square roots, both sides. You remember that step. That gives you this rather large, ugly thing. Then you do the quotient property of radicals, which you have not learned yet. But what do we end up with when we're done? We take away something next to x, and we have, ta-da, a formula.
So you need to copy that?
Yeah, that you're going to need to write down. There's the quadratic formula. So that big, long, ugly process I just walked you through, do you have to be able to do that? No. I just wanted you to know it comes from completing the square. All right, so take a minute and get that written down.
If I can understand this, I might like this one better.
You might. All right, now to help you get it locked into your brain, guess what I'm about to do here?
Well,
There's a
Oh,
song.
there's a song. This is not quite as cool as Parallel Lines, sorry. But it's real easy to remember. Y'all know Yankee Doodle?
Yeah.
Okay. It goes like this. The song sounds like this. X is equal to negative b plus or minus square root b squared minus 4ac, which all goes over to a. One more time. X is equal to negative b plus or minus square root b squared minus 4ac, which all goes over 2a. So you've kind of set it to music, it sticks in your brain. You need the formula. You need the formula. If you want to write the song down, you can write down the lyrics to the song, but it's just the formula. Okay, got the formula written? X is equal to negative b plus or minus square root b squared minus 4ac, and all that goes over 2a.
Can you go back one so I can see the picture of the really long
Maybe at the end. All right, we're ready?
No.
Okay. Now let's take a look at how this works. If you're going to use this to solve a problem, you have to start from standard form. That's what you did on last night's homework, right? Okay. So on last night's homework, you got it into the squared x number equals 0, right? Got to start with that. Is that in standard form? Almost. Not quite. 4x squared plus 7x. Okay? Now we're in standard form. Next step is to determine the values of a, b, and c. If you put it in standard form, it's in order already. A is right here. B is right here. C is at the end. Pretty simple?
Mm-hmm.
Okay. Now, here's where you go ahead and take it and plug it into the big, large, ugly formula. It's not hard. It's just a lot of plugging in and simplifying. Okay, you ready? We start with x is equal to negative b. Now stop there. If b was positive, it will become negative. If b was negative, then it will become positive. Right now, b is currently positive 7. So negative b would become negative 7. Plus or minus square root b squared.
minus 4
Okay, stop there. B squared. So b squared would be 7 squared, 49, minus 4ac, 4 times 4 times 4, negative 15, which all goes over 2a. What is 2 times 4?
8.
I'm going to recommend you do as much as possible mentally as you fill it in to avoid problems with the order of operations later. All right. Grab a calculator and do it by hand, whatever works for you. We need to simplify under the radical first. Order of operations says we need to finish what's under the radical. It's like a little grouping symbol. So what is 49 minus 4 times negative 15? What does that come out to?
289.
Okay? And all that goes over the same number 8 here. Okay. If we can take the square root of 289 nicely, we'll go ahead and do it. Otherwise, we're probably going to go straight to the answer at this point, 17. Okay? X is equal to negative 7 plus or minus 17 over 8. Fabulous. All right. Now, just like we had with completing the square, there's two answers. There's the plus version and there's the minus version. Yeah. Let's start with the plus version. We have negative 7 plus 17. What does that make?
10.
10. So 10 over 8 is a fraction. Can you reduce 10 over 8?
5 over 4.
Okay, let's do the minus now. Negative 7 minus 17 is
Negative 24.
divide by 8.
3. Negative 3.
Okay, good. Tell me a couple of ways that we could confirm those answers. Plug it back in, that'd be fine. Tell me another quick way you could confirm those answers. Take a look at the graph, see if the intercepts are right. Okay?
Where did you get 17?
17, what's the square root of 289?
Oh, 17.
Yeah, and that I did on the calculator because most people probably don't know their squares up through that. But you can do it on the
I just know
calculator.
up to 15.
Okay?
You know up to 15?
All right, are we good there?
I know 15.
Next one, see if you can tell me the first step. What's our first step going to be?
Standard form.
Standard form, okay. 2x squared.
Minus X.
I'm going to do it like that, and then tell me if you see any problems here. What's the problem here?
X
X
goes
goes
first.
All right, standard form would imply that we need to have the x and then the 7. Okay. All right, let's determine the values of A, B, and C. Well, let's see. A is the number next to x squared.
2.
So A is 2. This one's a little tricky because it's an implied number. It's not actually written. What number is next to the x?
Negative.
It's a negative 1, so B is going to be a negative 1. And then what's C? Negative 7. If it's missing entirely, as in if there isn't an x term, then it would be 0. If it's there but without a number in front of it, then there's one of them. Okay? All right, ready to roll. X is equal to negative b. Well, b is already negative, so negative b would be positive 1. Plus or minus square root b squared. What's negative 1 times negative 1? Positive 1 minus 4ac. Which all goes over
2a.
2x. Okay. Either mentally or with the calculator, let's figure out what's underneath that radical sign. 4 times 2 is 8, times 7 is 56. Negative times negative is positive. So 1 plus 56 makes 1 plus 56 makes 57. Yeah, you're doing all hard algebra and then we miss 1 plus 56? Okay.
Yeah.
Okay, now at this point you got a couple of options. You can go ahead and take the square root of 57. It's obviously not going to come out even. But if you do that, keep in mind, if you round during a problem and then use that number in further calculations, the earlier you round, the more error you end up compounding through the problem. You really want to try to keep it in that form until like right at the end. So go ahead and leave it as radical 57 right now. Grab your calculator, let's punch it in. That's as simple as it gets other than going all the way to the answer. So go ahead and grab your calculator. Let's do 1 plus square root of 57. Hit enter because the top needs to be completed before you do the division. 1 plus square root 57. Hit enter, should say 8 and change. Divide that by 4. And we got 2 point, what does it round to?
14.
2.14 is pretty close, right? Okay. I believe on this one, as it turns out, if you had done square root 57, write it down and then use that number, I think it actually comes out to 2.14 also. But it's off just by a tiny bit. Okay, same thing with minus. If you don't want to have to retype it, you can do second entry, which is the enter button. If you do it twice, it'll pull up your previous line from 2 lines ago. And then you can just change the plus to a minus. Don't forget to divide it by 4, and you get negative.
Negative
4.
4.
Okay. Alrighty, how can we confirm that?
Plug it in.
That's a good option. Remember, if you do plug it in, remember it's only going to be close, but it should be within about 100th or so. Or what else could you do? You can also graph it, and if you graph it, you can also confirm that it's about negative 1.6 and about 2.1. Got the process? Okay? All right, if you've got it, then you try it.
Oh, great. Oh. You're lost at both? Kind of am not a full weight.
Oh, you got to
Am I doing this right? I think that I just did too.
What do you have under the radical sign?
0.
What is 4 times 1 times 16?
64.
Okay, so we got 64 minus 64?
That's 0.
Which is what? 0.
0.
Can we take the square root of 0?
No.
Better find out.
Well, you can, but it's 0.
What is the square root of 0?
0.
It's 0? Okay.
All right.
So you have two different problems. You have 8 plus 0, and you have 8 minus 0. 8 plus 0 is 8. Divided by 2 is 4. Okay. And what's 8 minus 0? Still 8. Okay. Divided by 2 is still 4.
So it's
So
possible.
really, you only have one answer. Can you guess what the picture would have looked like
Oh,
if
wait.
you graphed it?
Oh.
Yeah.
Yeah, there's only
Yeah, you would have had just the 1.
Hmm.
Make sense?
Yeah.
All right, cool.
I like this. It's long and I
Again,
used
it
to I
works
like it.
every single time. Do we need more examples, or are we good?
We're good.
We're good? Okay, we'll flip through a couple of examples. All right, now let's talk about when you use each of these methods. Now we have all of these methods. It's like you got a whole toolbox full of tools, but you better know which one to use when. When do you use factoring?
When it's easy to factor and it's even.
When you got nice, happy, factorable things, like where you just have to find the times and the plus, and you can think of quickly what the times and the plus happen to be. Or if there's a GCF, okay? That would make it real easy for factoring. All right, when would you realistically use graphing?
When you have a capital.
When you have a graphing calculator, because that's really your quickest option
don't
if you
need
have
an
the
exact
technology.
answer.
Or if you don't need an exact answer, if you just want to see about where it falls, you can do that. Okay, finding square roots. You use finding square roots when there's no middle term, because that makes it real easy to just use opposite operations. Completing the square, there's one key thing that makes completing the square much easier. What makes completing the square easy?
B is the number.
When the middle number is
Even.
even, okay? And then quadratic formula is kind of the leftover.
The OP one.
The who?
OP.
Which is?
Overpowered.
So which one?
Overpowered.
The overpowered, okay. If you say so. Quadratic formula is the one you kind of fall to when there's nothing else immediately obvious, because it's big, but it works every time. Okay? See if you can tell me. For some reason, my full screen keeps popping out of full screen. Okay, if we had 10x squared minus 7 equals 0, what method would we most likely use?
The one that doesn't need a middle term.
Which one doesn't need a middle, which one works best without a middle term?
Square roots.
Taking square roots. Yeah, in this case, you would add 7, you divide by 10, you take a square root, and you're finished. Okay? How about the middle one? X squared plus 4x equals 0.
Completing the square.
That's a decent option. Why is that a decent option?
Because the B terms.
The B term is even. However, there's something even easier. Do you notice these have a GCF? Yeah.
X.
Okay, if you had just factored out an x, that leaves x plus 4, x equals 0, or x equals negative 4. That's as long as it takes. Wow. So factoring would really be best because it has a GCF, okay? And then this last one, 5x squared plus 9x minus 4.
Quadratic equation.
You're pretty much using the formula there because it's not easily factorable. It's not, I mean, there's really nothing else that works nicely, okay? All right. If you can tell on any of these where they go, come drag it to the right spot. And if you get it wrong, it's okay because we can move it.
I should play the button. Do it. No.
Okay? What else we got?
I'm just ready to go up there.
Okay, well that leaves this one. And I'm going to tell you not one of these is right.
I say factoring goes to the second one.
Right, why square roots on that
Because
one?
there's no middle term.
Oh, no middle term. You just have to add 10, take a square root. So that one is now all set. That one's all set now, okay? Are there any of these that have an even for a middle term?
Yeah, Oh,
So, yep, that'll work. That's good for completing the square.
that's what
Now, let's see, which of these two would you rather factor?
Both.
the second one.
Why can you factor the top one quickly?
Because it's 12 and then there's
Oh,
7,
and
which would be 3 and
Let's
4,
do
which added
3 and 4 multiplies to 12 adds to 7, which kind of leaves.
that to that.
That one's the last
The
one,
with all
and
the odd, uneven numbers.
the one with all the ugly numbers is pretty much
Not
quadratic
necessarily
formula.
ugly, just odd.
Okay. Alrighty, finally, let's go ahead and apply it. How are we doing on time? What are we at?
9.
We've got about 10 minutes. Okay. To use the quadratic formula, we're going to take a look at this particular example problem. Number of films produced worldwide. We are told in the problem that the number of films produced worldwide can be modeled by the function y equals 10x squared minus 94x plus 3900. Okay. Read the problem. There's nobody there. Never mind. Okay. We want to know when the number of films is equal to 4,200. I want to know when the result is 4,200. What does that tell you?
Y is 4,200.
Y is 4,200. Okay, so instead of having Y, we're going to fill it in with 4,200. Okay. Now you got lots of ways you could do this. You could make a table on your calculator and you could look for a result of 4,200. There's all kinds of things you could do. You could do guess and check, but we've got a couple of strategies that are just waiting to be used here. Would you use factoring? You want to factor that puppy? I don't. Okay, factoring not so much. What else? Completing the square? Not really. Okay, well what does that leave? We're pretty much stuck quadratic formula. Is it in the right form?
Yeah. No.
Almost.
Yes.
What do we have to do to get it in the right form? Okay, that'll give us our nice 0 that we're looking for. 10x squared. Okay, now what? We got in standard form, now what?
Using the
You
formula.
need to plug it into the quadratic formula.
Lucky us. Okay, x is equal to negative b. Well, b is currently negative 94, so what's negative b?
94.
Plus or minus square root. It's going to go right over my writing over there. B squared. B squared. What's b squared? 94 squared.
88,836.
There you
You
go.
didn't just get a decimal.
B
by
squared minus
plus square
4ac.
94.
4 times 10 times negative 300,
Wow.
which all goes over
2A.
2a.
Wow.
Okay.
Wow.
All right, bust out the calculator. Let's figure out what 8836 minus 4 times 10 times negative 300 happens to be.
Watch during the SATs, you hear that song. Just
Hey, you never know. I have actually overheard students humming things like the Parallel Lines song during a EOC. Okay.
20836.
20836. Okay, so x is equal to 94 plus or minus.
Can't you see
Gave me an error. So beautiful.
If you're getting an error, you're
No.
probably using a minus sign instead of a negative sign where the 300 is, would be my guess.
I've done that before.
It's an easy mistake to make. Over 2a, which is 20. Okay, type this in as follows. 94 plus square root 20836. Hit enter. Then divide by 20. And what do we get for our answer?
11.9.
Pretty much 12, okay? Now, if you don't want to have to retype that, do second enter and do it twice to pull up the previous, the line from 2 lines ago. Change the plus to a minus, repeat the process. 94 minus radical 20836, hit enter, divide by 20, hit enter. And what's our second one?
Negative
Negative
2.5.
2.5.
Okay. Now, is it possible to have 11.9 years? If you are looking at a construction project on, down on 3040, can it take 2.5 years to complete?
Yes.
Yes, it can. However, in this context, we're talking about a
Years after.
year, not like, in other words, 2013. If I ask you what year it is this year, do you say it's 2013 and 1/4? Well, it's March.
That's what we'll do.
Wouldn't you say 2013 and 1/4? No. What do you say? It's 2013. So no, we really don't want fractions and decimals here because we're not talking about how a length of time, we're talking about a year. So what year would 11.9 be?
12.
Well, that's 12, and it's 12 years after 1971. So what would that imply?
It's even.
1983.
The big one.
Okay,
Yeah.
now negative 2.5 might as well be negative 3. 3 years before 1971 would be what?
1968.
Okay, now there's only one problem. The function applies between 1971 and 2001. Anything within that domain is valid. Anything beyond that domain, we do not know if the function applies. So looking at these two answers,
1983.
we will keep this one, and we will have to say that that one is not in the domain, so we don't know if it applies. It's like the interpolation extrapolation thing, okay? The 1983 is an interpolation. It's within our set of data. We think it's good data. 1968 is not. Can you see how you could well get two answers, neither one of which will work?
Yes.
If one of them was negative, then it's before the start. And another one might be, if x was 40, that might put you in, what, 2011? Is 2011 a year? Yes, is 2011 a year in this set? No. So you have to be real careful about which ones work. It's possible that neither one of them could work. And what would that mean in the context of this problem? I asked when it equals 4,200. If both of your answers are not in that set, then what would that tell you?
It doesn't equal 4,200 in that section.
Exactly. It may not ever equal that number in that range, and that's okay. All right, any questions? All right, your homework for this evening. Do you remember yesterday you took all of your numbers and you put them all in standard form? Yeah, on the back side of that, what was it called? Did you hear? The Did You Hear puzzle? Okay, now that you've got them all in standard form, plug them into the quadratic formula. X is equal to negative b plus or minus square root b squared minus 4ac, which all goes over 2a. Very good. Okay, so that's your assignment. Any questions?
How many minutes do we have left?
You have 5 minutes left in class.